So the graph of a rational function. So a rational function, we got a polynomial over another polynomial. Anytime we find our x-intercepts, we're always going to let y be 0, right? So we go ahead and let y be 0. Our x-intercepts come from the numerator, right? If that's 0, then this will be true. So we've got -1. So our x-intercept is -1, our y is 0. So there's our x-intercept. Our y-intercept, on the other hand, we're going to let x be 0. So let's let x be 0. Looks like I got 1 over -9, so -1/9. So I have the point 0, -1/9. So like right there. Our vertical asymptotes came from our denominator, right? Where's this thing undefined? Remember, we took that denominator, go ahead and factor it. And that'll give us the equations for the vertical asymptotes. So in this case, x equaling 3, -3. We'll never touch 3, -3. We'll never touch 3. Never touch those, right? Horizontal asymptote. This is where we examine the degree of the top. The degree of the numerator here is x to the 1 power, right? So the degree of the top is 1. Degree of the bottom is 2. So n is less than m. The degree of the top is less than the degree of the bottom. If n is less than m, automatically the horizontal asymptote is y equals 0. In other words, what that means is as x goes to infinity, this number on the bottom will get so much bigger than the top. So as x goes to infinity or negative infinity, it approaches 0. It's like some small number over a huge number. It's like 0.00000 whatever, right? So it's approaching 0. So we have anytime the degree of the top is less than the bottom, automatically it'll be y equals 0. Okay? Is your rules on that. And then after that, we're just plugging some points in to kind of see what this thing looks like. And it's kind of tedious, but when you're doing it by hand, that's what you want to do. You want to plot a few points. And notice we did cross that y-intercept right there. Interestingly enough, we do cross it. It's just at the extremities, what's going to happen is you're going to get closer to it at the extremities. But let's plug some points in. I only have 2 so far, so let's throw in, let's go to the left of -1. I already have this one. Oops. So let's go with like -2. I'm not going to throw in -3 because that's my vertical asymptote, but it'd be nice to throw in like -4, -5, a few to the left of that vertical asymptote. It'd be nice to throw in like, 1 and 2, a couple to the right of x being 0. And then I got to jump over to the right of x equaling 3. So maybe 4 and then 5 and so on, right? So I'm just plugging them in one by one. In fact, we could be a little bit lazy and we'll even let our calculator do it for us. X plus 1 over x squared minus 9. X plus 1 over x minus 9, right? But we're putting in values. Let's see, the first one was -1. Oh, we already know that one. I'm sorry. That was our 0. We got to go to the left of that. -2 is our next one. So we throw -2 in. It looks like I get 0.2. So then I put that on our -2 gives us 0.2, -2, comma 0.2. I could throw in like -2.5 on there. Would not be a bad one either. 2.5, 0.5, and I get 0.5454. So a little bit higher. I could throw in like even something even closer, like -2.9. And what you'll see is it'll start shooting up. And you can plot some points over here. Similarly, throw them in, and you're going to see that thing kind of go down. Let's throw in like something to the right of x equaling 3, like x equal 4. And you get 0.7. So 4 gives you 0.7 something. 0.7, so I'm pretty off on this. As you go out, though, what's going to happen is this is going to get even closer to 0. So it'll be a little lower and then a little lower. And as you go out, it's going to get even closer and closer. As you go to that way, it's going to shoot you up. So you could put in like 3.5, something even closer to 3, like maybe 3.2, and you'll see it's pretty high. That y value is pretty high, right? So you're just plugging points in at this point. And I'd throw some in over here as well. And you'll see as I go out, I'm getting closer and closer to that green line, right? And that's kind of the name of the game of this, right? With our rational functions. Let's do some more here. Let's find our x-intercepts on this one. 2x squared plus 4x. I'm going to take a 2x out, and I'm left with x plus 2. So I have 0 and negative 2 will be our x-intercepts. Y-intercept, now let's let x be 0. So I got 0 over negative 15, so I got 0. We already knew that, 0, 0. Vertical asymptote, let's take our denominator. Sorry, what I do here? X squared plus 2x minus 15 equals 0. So I got x plus 5, x minus 3 equaling 0. So I got x equals negative 5 and x equaling 3. There's our negative 5. There's our 3. Okay. Horizontal asymptote. Notice the degree of the top is 2. Degree of the bottom is 2. If they're the same, if the degrees are the same, the rule is if the degree of the top's equal to the bottom, then we take the leading coefficient of the top over the leading coefficient of the bottom. So in this case, it's 2 over the 1 in front of the x squared. So 2 over 1. 1, 2. So I go ahead and put on there y equaling 2. And then at this point, again, we're plugging in a bunch of points for this. Be nice to throw in like something between 0 and negative 2, like negative 1. I'd throw in like negative 1 would be a good one. Something to the left of negative 2, negative 3, negative 4. At negative 5, I have a vertical asymptote, so you can't throw anything in there, but something to the left of that. And then something to the right is 0 as well, so like 1 and 2. At 3, I have another vertical asymptote, so I can't throw anything in there, but I could throw in 4 and 5, and so on, right? So I have, and I'm throwing it into, you could use your calculator again if you want to, 2x squared plus 4x over divided by, what was that, x squared plus 2x minus 15, right? We're throwing in negative 1, negative 3, negative 4, so I throw in like negative 1. Anyways, it gets kind of tedious. Definitely. Let's throw our negative 1 in. And I get 0.125. So let's throw negative 1 in, and we got 0.125. So it's right there. I could throw in -3, -4, and I'll give kind of what this thing kind of looks like. What it does is it starts going down. Once you throw these in, it'll shoot it down. So it's vertical asymptote. And those, in that case, again, plug values in. Over here, let's throw in 4. I think 4 would be a good one to throw in. Somewhere right there. Looks like we got 5.3 repeated. I threw 4 in. So it's up here. 3 repeated. I could throw in 5, and anyways, you could throw in some more, and this is kind of what you're going to see over there. Plug in some points there. Plug in some points over here, and you'll start seeing that as well. Okay. So kind of a plug and chug is kind of the name of the game after you've determined some of these properties on this. Well, let's find our x-intercept. Let's let y be 0. So x being 0. Now let's let x be 0. 0. Let's find our y-intercept. Where's this thing undefined? X minus 2x plus 2. So we got x equaling -2, x equaling 2. Okay. Now we got to decide. We just got to plug in a bunch of points in between them. Like maybe I'll throw in, like 1 over 1 squared minus 4. I got 1 over -3, so -1/3. 1 comma -1/3. Throw in like -1.5. You're going to see it kind of shoot that down. I could throw in -1, and I'm going to get a +1/3 on that, and it's going to shoot that up. Again, I could plot some more points on that. And same thing over here. Now, the one thing I didn't graph yet is the horizontal asymptote. If you notice, the degree of the top is 1, degree of the bottom is 2. If the degree of the top is less than the bottom, it's automatically y equals 0. So it's going to approach that. Again, plot some points to kind of see that, but you're going to get closer and closer to that as you shoot out. Same thing over here. You're just approaching it from the underside. And you kind of shoot that out, but you're just plotting a bunch of points. Very tedious. Very tedious. Okay. Now, the next one is that one flipped over. X squared minus 4 over x. So where's our x-intercepts? Well, those come from the numerator. So plus or minus 2, 2, 0, -2, 0. Y-intercept, I'm going to let x be 0. Well, I can't do this, so I don't have any y-intercept. Why is that? Well, because I have a vertical asymptote right there at x equaling 0, right down the middle. So I'm not going to have a y-intercept. It'll never touch a vertical asymptote. Now, if you notice on this one, the degree of the top is 2, the degree of the bottom is 1. So if n is greater than m, there's no horizontal asymptote. Furthermore, if it's only 1 degree more, if the top is, it's only a difference of 1, then you're going to have an oblique or slant asymptote. And so what you'll have to do is you got to take x squared minus 4 and you got to divide it by x to find the slant or oblique asymptote. So you got to actually do the long division. So you go, okay, let me go x squared plus 0x minus 4. Let me divide it by x plus 0. X times x squared, x times 0, 0x. Don't forget to change those signs. There's my remainder. So y equals x plus remainder over divisor. And your oblique asymptote will come from that quotient. So it's y equals x. So y equals x, that's your oblique asymptote. Because this will go to 0 as x goes to infinity, right? It's like -4 over a huge, huge number. That's going to go to 0. Because what you're trying to determine is, what does this do at the extremities? So let's go ahead and put that oblique or slant asymptote, y equals 0. I'm going to go ahead and graph that linear line. Y equals x. Y equals x. And then what I'm going to do is I'm just going to plot some points. So we have y equaling x squared minus 4 over x. Let's throw in like 1. So I got 1 squared minus 4. I got -3 over 1, -3. Let's throw in, we already know 2, 0. Let's throw in 3. I got 3 squared minus 4, 9 minus 4, 5 over 3. So 3, I got 1.6. Anyways, I could keep going with this. 4 would give us 16 minus 4 over 4 to 3. But what you're going to see is it's going to get closer and closer and closer to that slant asymptote from that bottom side. And then from the, it's similar over here. You just graph some points. You're going to see that thing kind of approach it from the top side there. You got to plug some points in there. Okay. All right, my last scenario is what happens if, let's go ahead and factor this top. Let's see, that'd be +2 minus 4. Let's go ahead and factor the bottom. Notice that these cancel. Now, what does that mean? That means this function, because that's a different function, behaves like the simplified form, except you have a hole at that undefined point, right? Wherever this, wherever that canceled part equals 0. So in other words, at x equals 4, you'll have a hole there. So it looks exactly the same as the simplified version, but remember it's undefined at 4. So you got to put a hole in there, right? But everything else is the same. So, where's the hole at? Well, where's the hole at? Well, we know it's at x equals 4, but where's the y value? Well, let's look at the simplified form, because this one doesn't have a hole. So we plug it in. So we have 14 over 8, or 7 over 4. And I'm going to put a hole in there. So 4 comma 7 over 4. 1, 3, 4. So I have a hole right there at 4 comma 7 fourths. And then the rest of this I'm going to do the same. So where's my x-intercept? At -2/3, 0. Where's my y-intercept? Let me let x be 0. 2/4 or a half, so 0 comma half. Where's my vertical asymptote? Now I only have a vertical asymptote at the one that did not cancel at -4. At that +4, remember the one that canceled, that's a hole, right? So if you have factors that cancel, you have a hole there. You don't have a vertical asymptote there. So in this case, we only got one vertical asymptote, x equals -4. Horizontal asymptote, well, the degree of the top is the same as the bottom, so it's 3 over 1. Take the leading coefficients, so y equals 3. Y equals 3. And then at this point, you're just graphing points. So throw some points in. You're going to see it hit through there. Again, notice this is a big old hole right there. You have a big hole right there, right? graph some points up here as well, and you'll see it looking kind of like that. All right. So when factors cancel, you have a hole right there. Keep that in mind. All right. Thanks for listening, guys.